Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon to all the participants. Welcome to the Internet of Things with Nodemcu and Mqtt Inventor Workshop. I am Nurul Iza binti Yusaini, the host for today. Before we start with this session, I would like to invite Muhammad Aminuddin bin Abdul Muttalib to start our workshop with the recitation of Dua. Please welcome.
Bismillahirrahmanirrahim. Al-Fatiha. أعوذ بالله السميع العليم من الشيطان الرجيم. بسم الله الرحمن الرحيم. وقال ربكم ادعوني أستجب لكم. أعوذ بالله السميع العليم من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين. اللهم اجعلنا هذا الجمع المرحوم وتفرقنا من بعده تفرقا معصوما ولا تجعل لهما فينا ولا معنا شكيا ولا محروما. ربنا عليك توكلنا وعليك أنبنا وإليك المصير. اللهم طول أمرنا وصحح أجسادنا وثبت إيماننا ووسع أرزاقنا وأحسن أخلاقنا ونور قلوبنا برحمتك يا أرحم الراحمين. اللهم اجعلنا من أهل الخير واجعلنا من أهل البركة واجعلنا من أهل المغفرة. اللهم اجعلنا من أهل الجنة واجعلنا من أهل الفردوس أعلى برحمتك يا أرحم الراحمين. اللهم اجعل مجلسنا هذا المجلس مجلسا مباركا صاحبنا وأهلنا وجيراننا وضيوفنا برحمتك يا أرحم الراحمين. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا النبي الكريم وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Amin, Amin, Ya Rabbal Alamin. Thank you, Muhammad Aminuddin, for the recitation doa just now. Moving on to our next agenda. Today's event will be held from 2 p.m. until 5 p.m. For your information, our speaker for today is a senior lecturer at the Faculty of Engineering, School of Electrical Engineering, University Technology, Malaysia. If participants have any questions throughout the talk, you can comment in the chat box and I will ask the questions to our speaker on your behalf, or you can just turn on your mic to directly ask the speaker. So without any further delay, I would like to welcome our speaker, Dr. Fauzan Khairi bin Cik Harun, to begin the session. Welcome, Dr. Fauzan. The stage is yours.
All right, thank you very much, Nurul Izzah, for the introduction. Welcome everyone to the session today. Can everyone hear me and see my screen?
Yes, Doctor.
Yes, Doctor.
Okay. All right. So today I will do a short introduction of Internet of Things for using Nodemcu and MIT App Inventor. So before I start, the flow of class today, I will do this like a tutorial based class, and I'm sure there are many videos out there that is much better than this in terms of tutorial of Nodemcu, tutorial of communicating with MIT App Inventor or using other types of technology in order to do IoT. I'm very sure there are many tutorial, much better tutorial than this. So I just would like to remind you that the difference between this class and the other class that you can see online is that here you can ask questions. Online, on YouTube, on whatever you watch, it's very difficult to get answer of the instructor, right? But here you have the opportunity to ask questions. So that is the only difference between this class and the one that you watch outside there. And many of the codes here also I get from different places online, so you probably will see this code again and again online. So I just would like to remind you, if you have any questions, you have to take this opportunity to ask questions. I have put here a link, and I think also the the coordinator, the secretary also have put this link. Any question that you have about IoT, you want to ask this sensor, that sensor, can this do this, can you do this, what is server, whatever you want to ask, we will go to the question and answer session later on, but you just keep asking. I will look at this question and answer page a lot of times, and you will be able to get a direct answer from me if you have any questions on anything. I'm saying this because you probably will find other tutorials online, and that will be of benefits to you as well. But this class, the only difference is you can ask questions, and I think the most important is for you to understand the whole concept of IoT, how things are communicating with each other, what are the tools, what are the communicating language or protocol. So once you understand this, you can just search Google and try to find the answer. But for you to understand the overall concept, that is my intention today. So the flow of class today, the notes, oh, I forgot to give the notes. I should give the notes soon, I think, to one of the coordinator, and he or she will send it to all of you, or maybe I should just share it in this group. Hold on, I think I better just share it in this group, because it is important for you to use the notes that I am using now, because I will follow the tutorial exactly as in here. Then we will try to get the output from here. Oh, silap lah. Kat mana ni? Download. Okay. So I will share this, I think, in my GitHub. If you go to the GitHub page, search this link up here, APAUI ESP8266 server, then you will find these notes available there. I think that is the easiest way of doing this. Find the... Oh. Okay. Sign in. Okay, let me add file. So all the codes and the notes will be in GitHub. So you just go to github.com/apauaie/esp8266 server. The notes are available there now. So let's go through this again. So okay, I hope everyone have opened the Menti form, so you can start asking question from there. All right, so let us start with the concept first before we go into the real coding. So what I am sharing today is about Internet
Sorry,
of
Doctor.
Things. Yeah.
Can you share the GitHub link on the chat?
Okay, hold on. Okay, you can go there and look for ESP32 ESP8266 ESP8266 server. Okay.
Okay, Doctor.
It's in the chat. Okay, so you can go in the chat. There is a a link. You can go to that link and then search for ESP8266 server. So that is the file. There's a lot of page in there, so you can go to that one. Okay, so today we will look at Internet of Things. Okay, so what is actually Internet of Things? So Internet of Things is nothing more than your things is connected to the internet. So you can communicate in between each other by using, okay, it can communicate between each other by using certain communication protocol. So you have your phone can connect to the internet, your tablet, your desktop, your server even, and everything is in the cloud, right? So in the server. So you can imagine that all of these are in the server. When your desktop want to get something, it just call the server, get the information, and you will get the information. Your phones, your laptop, or even today we are going to use Nodemcu, or you can use Arduino, you can use ESP32. So there are a lot of different tools that you can use in order to communicate with the server. So whatever have the capability to connect to the internet and do certain things like send data, receive data, that is called Internet of Things. Nowadays, you can have a car that is Internet of Things. The car can communicate to the internet to get information of weather, for example. If the weather is certain, then it can make certain decision for the car. Nodemcu can get information from the internet, or you can send information to the internet. For example, you connect your controller to a sensor, maybe what do you call that, soil moisture sensor, for example. You connect this to a soil moisture sensor, you get the value for the soil moisture sensor, you send it to the internet, and then you save it in some sort of server, and your tablet and your phones, your laptop will go to that server to get this information. So you can imagine that this is not directly going to take from the Nodemcu, but it's going to a server. But today what we're going to do is we're going to make your Nodemcu as the server. So this will become the server for today, and everything else will communicate directly to the server in order to get information or to send information. You can imagine we can collect information, keep to the server, or the server can also get information from outside, use that information from outside to do something. So that is essentially what Internet of Things is. And the communication, there is a lot of communication protocol that is available out there. Some communication you use Wi-Fi, some use Zigbee, some use Bluetooth. So there are so many others. But the Nodemcu that we are using today only support Wi-Fi, so we are going to focus on Wi-Fi only. There are many other methods in order to do this, but today we are using Wi-Fi because it is one of the most the easiest for us to do, and the cheapest probably by using the Nodemcu. Okay, now I want to talk a little bit about computer and server. So what is basically a server? Let me fix this. Okay, so what is basically a server? A server is something that serves something. Like, for example, you go to a restaurant, a server is someone that serves you food, right? So he serves you with something. You request for something, he serves you with that thing. So you request for nasi goreng, then he will bring you some nasi goreng later on. So essentially, a server is a place where there is information that you need, and you can request from any device to the server. So this is maybe your laptop. You can request information from the server, and the server will respond with a response. You send a request, the server send back a response. So for example, you go to www.google.com, right? So the server of google.com receive your request saying that you are trying to access, then they will send you a response in terms of HTML, a lot of HTML code. When you receive it on your site, it will display it on your computer. I will give you an example here. So for example, another one. For example here, when you type google.com, so what will happen is Google will receive the information and it will send you uh, this code here. You can see on the right side of my screen, there's a lot of garbage stuff that you can see here, but when my computer interpret this, it will see Google nicely formatted like this. But actually what is sent back to you by the Google server is the HTML data or JavaScript or things like that, and you need to format that, you need to process that in order to get this information like you see here. So essentially, that is what is happening in a server and a computer. So you imagine there is a server, you can connect this server with many different things. Okay, for example, you have a mobile phone. You also want to connect to the server, you type the address www.google.com maybe. Then you will get the information from the server. And actually all of this address have an IP address to it. Okay, what is an IP address? IP address is just a number where you can locate this server. If you imagine we have a house, I have a house, you have a house, somebody else have a house. So all these houses have different address. Otherwise, the postman cannot find the house. This one probably is number 32. This one is number 33. This is number 34, right? So these are address of the house. 34 Jalan XY1, for example. So when the postman wants to find this address, he just go to the location and see the number. He knows, okay, this is the address, and he just give you the package that he has. Maybe like that. Okay, a package that he has to number 32 because that package is for number 32. And if number 32 want to send some package back, he will send to the postman. Postman will bring it back. So I'm just using this as an analogy where actually when you type the address, it actually is going to the IP address of that location. Okay, this is important for our next task. So I'm just telling you all this so that we can understand this better. So if I okay, if I go to this location here, I can enter www.google.com and I can see that, okay, this is the IP address of google.com, right? So whenever my computer try to get any data from google.com, it will use this IP address. It will request from this address. So this IP address is the location where you want to do your process. So same way as your IoT later, your IoT device will need to go to some sort of server, request something from the server, get back something from the server, and do processing on that thing. So that is essentially what we are doing today. There are many types of communication in between your computer and the server. These are called HTTP requests or HTTP methods. These are the most common way to communicate in the internet. Your computer, for example, will send a GET request so that the server will know, okay, this is a GET request. I will process this and I will send information back to the client. Or you can use POST request. You can use PUT request. You can use delete request. So there are many other requests that is available. These are only 4 that I'm showing you here. Today we are going to use GET request, GET HTTP request. Okay. For IoT, there are many other ways that you can do this. Another one that is very popular is using Mqtt, which I will not cover today, but there is also a Mqtt server. You can send information using Mqtt format and protocol. If you can imagine, this is just like language. So for example, this GET language is the Chinese language. And this Mqtt is a Malay language. So you can imagine if your device is speaking Chinese to Mqtt. It doesn't really understand that. If you can imagine your device trying to speak Malay to this server, but this server only understand Chinese, so he cannot respond. He doesn't understand the information. So that is the analogy of this. So that is why it's important for us to follow the protocol that is given. If you are using GET request, language of GET request, GET HTTP, then you use the GET HTTP method in order to communicate with the server. If your server use Mqtt, then you use Mqtt in order to get the information from the server. So today we are going to use HTTP GET request in order to communicate in between all our devices. And this is the most common, I would say, in the IoT world, but Mqtt is another one that is very popular and can do the task very well. So today's task is quite easy because we only have 3 hours. Usually I do like a 1 or 2 days workshop for this, but because it's very we don't have enough time. I have already compressed this to very short, but you have all the tutorial. But I don't want you to value the tutorial so much because the tutorial online is much better than the one that I have here with the step-by-step step to do this. What I want you to get in this course is the process and the understanding of how this talks to each other. For example, today what we are going to do is we are going to use the ESP32 and we are going to use the Arduino IDE, ESP8266 Arduino IDE in order to write code so that our ESP32 can communicate with sensors. I will not use any sensors today because of lack of time, but I will use LED on here. There's one LED, if I'm not mistaken, here. And also I will use a touch sensor. Okay, so whatever it is, there's only two ways of communicating with your microcontroller. Either you are using analog or you are using digital. Analog, you can come in, analog, you can go out, analog in and analog out. You have also digital in and digital out. What is digital in and digital out? Digital in means your sensor is, your microcontroller is reading the sensor. So this one, is it in or out? Anybody can comment? This device, this is a relay. This is an in or out device. Input or output? Anybody? A relay, or maybe this one is easier. LED, is it an input or output device?
Output.
Okay, good. Output because you want to send data to it so that it will react to your data. You cannot read any value from this thing because it is a device that can shine light whenever you want it to shine light. So this is a digital out, right? You have your sensor, everyone have their own different sensor for your capstone. So you need to identify whether it is analog, it is digital, whether it's I2C, whether it's SPI. These are all digital protocol, different language. Like I said, Malay and Chinese just now. This is just different language of the device communication. So if the device is supporting SPI language, then you use SPI language for your microcontroller. If your device is supporting I2C, then you use I2C. If it is only digital or analog, then you use digital or analog. In this example, this is using analog input because this one is giving a value to your microcontroller. It is a sensor. So all sensor is an input. Easily said, all sensor that give data to the microcontroller, that is all input. All actuator or things that actuate, things that react to the signal from the microcontroller, like motor, servo motor, RGB LED, all that are actuator or output. Or this one is a relay. Relay is the one that you use if you want to control the electric in your house. This one takes 240 volt and this one takes 5 volt. You can trigger the 240 volt by just using a 5 volt or 3 volt in this case of the Nodemcu. So today I am not going into the details of communicating with all of this hardware, but I'm going to go into a little bit of digital and a little bit of analog. As long as we can read digital, read analog, and send digital out, analog out, we will not cover today, but I will focus a little bit on digital and analog, and then we will use this information to communicate with the server. In this case, this will become the server. This one is the one that serves information. So your phone, your computer, or whatever can connect to the internet, can connect to this server, and this server will give you response based on what request you make to the server. So for example, in this case, your phone make an HTTP GET request. Your server will get that request and respond depends on what your request is. Okay, so your phone will request something from the server. Your server will send something back to the phone as a response to the phone, and the phone can process this information how he like. And we also will go into trying to use voice recognition on the phone in order to do this. And because this Capstone, you don't have much time, we are using Mqtt App Inventor as an easy way for us to understand what is going on. But if you are doing more complex tasks for your FYP, when you are doing master, then I think much better if you look into code base, which is much more flexible. Mqtt Inventor can do many things, but it's very limited to the things that is already available in there. If you want to do more, something extra, you need to go into real coding in order to do that. All right. Okay, and you can keep the question coming. If I see any questions at the moment, there is no questions yet. Is there any question? Let me just check very quickly. Here. Okay, no question yet. So if you have any question, just write it down. I will answer it straight away if I see any question. But I hope you understand the concept here. I don't want you just to come here, do the tutorial and manage to do the tutorial, but you don't understand why are you doing it, how does it work, because you can get many tutorial online, but to get the understanding of the theory is much more challenging. So today is quite simple. We're just going to make a server with Nodemcu. We're going to make a mobile app that can do voice recognition, and we can get data from the server using HTTP GET, and the HTTP GET, the server will respond something to the phone in order for the phone to process the information. And the phone here can be your laptop, can even be your desktop, can be another Nodemcu, because all these are client. The server are here, everything will talk to the server. So this is the important part of the server. Let me just remind you that Nodemcu can be server, can be client. It depends on the code that we program on it. So today's codes, the code that you get on the GitHub just now. Okay, let me just go to the GitHub again. You can go to the here also can ESP 8266 web server. So here the nodes is already here, the code is already here, and the code for the mobile apps is also already here. You can actually just run this by using this code, but my intention today is for us to go through the code and understand what is happening inside the code. All right, so let's go through the tutorial. We will do hands-on from now on. So I think I will open if there is any questions first before we go to the hands-on, where you will do all the stuff following the tutorial that is available here. Anyone wants to ask any questions? At the chat. Okay, many people are answering. Good. All right. Any more questions? No? No, this is opportunity for you to ask, you know. Otherwise, this is just gonna be the same tutorial as you see in YouTube, in Facebook. where you can just listen to the person, but the person doesn't respond to you. Oh, is it in
That's what I have.
Mentimeter? But it's not updating here. Huh? You write in the Mentimeter. Let me just refresh maybe. I don't. Oh, there is some question. Okay. Sorry, I have to go down. Okay. Sorry. We have 15 questions. IoT field is more related to electrical student or electronic student. Basically, now there is not an option for you to choose because IoT is everywhere. Even mechanical students are doing IoT now. IoT is basically a combination of computing where you learn about the HTTP request and all that, because in electrical you don't learn about the HTTP request. All these are in faculty of computing. But in Faculty of Computing, they don't learn about the electronic or electrical course. So basically, this is a combination of computing stuff and also electrical or electronic. But I would say anybody who has this knowledge, there is an advantage for you in this future world, because IoT is going to go everywhere. Even in cars now, there is IoT. Even in machine, a lot of machine, there is IoT. Your fridge can do IoT. Your house can do IoT. So it is actually everywhere. Even civil students are now looking into IoT with the home automation stuff. Right? Okay. Sorry, next question. Okay. Later I will share you this, how to change between ESP8266 and 32. Basically, this is just a library thing. You need to change the library so that you use the ESP32 library. This one is... kenapa dia dah pusing balik? How to connect two sensor by connect to one MCU, not MCU. Can you show example of the connection? Okay, not MCU is actually a controller that can connect to many things as long as you have the pins. So if you have the not MCU, you have many pins. So you have 20 or something pins. So you can connect actually 20 sensor. You have humidity sensor, you have color sensor, you have I don't know, fire sensor, heat sensor, whatever sensor, you can connect 20 to all. They're not MCU. Basically, the difference is when you read the value. For example, you do digital read, right? When you do digital read, you just mention what you connect to sensor pin 1. GPIO 2, for example. So this one you connect to pin 2. You connect a humidity sensor. So when you read the value, you know you want to read humidity sensor. So you read pin 2. If you want to read from button, you connect this button on pin 15. So when you want to read the button, you just go digital read 15. So there is no fixed value here, because you are the engineer, you are the designer, you decide what happened here, what you want to connect to pin 15, how do you want to read this value, what you want to do with this value. All you are the one who decide. You want to ignore this value, you want to use this value to compare with another sensor value. So all that is in the coding. So we will see a little bit about the coding soon, but let me just go through this first. Why is the mechanism connected to ESP32? You need to check the pin, and you can use I2C or SPI if you want to have more pins. But I think for purpose of Capstone, it is more than enough to just use one ESP32. You can connect to more than 10, I believe, sensors already. If you see the pin here, sorry. If you see the ESP32 8266, I will just show ESP8266 because we are using that today. But you can just search for ESP32. So you can see here This ESP8266 have GPIO 14, GPIO 12, GPIO 13, GPIO 15. All this can be connected to sensors. So you have quite a lot to connect to sensors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You can connect to sensors. This one is using SPI communication. You can connect multiple devices for this one. And this is the I2C port. This one you can use same pin. Only 2 pin, but you can connect actually to 10 sensor. But they need to be I2C capable. If the sensor is not I2C capable, you cannot use this pin. This is special language for sensors. So you can see a lot of pins can be used. Okay, let me go through again. Okay, this one. Okay, maybe since somebody bring this up, do you say MIT Inventor over Bling? Bling is an easy way in order to achieve this. You probably can use Bling to test out, to prototype your device. But later when you go to industry, they don't want really to use Bling because Bling have a lot of limitation that is available. The reason I'm teaching you MIT Inventor is because MIT Inventor is quite flexible. If you want to change this MIT Inventor to use a real mobile apps using Ionic, using Flutter, using Android or iOS apps, Xcode, all you can do. But if you use Bling, it will be limited to the Bling function. It will be easy, but for your future, it will not be good for you because it is very limiting in terms of the function and the capability. So I'm teaching you something that is very general that you can use very easily for your future when you become a real engineer. How can I rewrite a daily timer since a long period of time? Daily timer, usually we don't create with the Nodemcu themselves. You can try create the daily timer with what do you call that? The mobile apps. If that is possible, I think we can have a look at this timer. We will have a timer of 3 seconds just now. But if you want to have 24 hours, I think the mobile phone can support that. But using not MCU, it will be much more challenging. Okay, many of you are using ESP32, so I will show also how to use the ESP32. Yes, ESP8266 only connects to Wi-Fi. Okay, 8266 only connect to Wi-Fi because it only support Wi-Fi. But ESP32 supports both Wi-Fi and Bluetooth. Bluetooth low energy. So if you want to use Bluetooth, you need to use ESP32. If you want to use Wi-Fi, then ESP8266 is enough. Booking reservation system, yes, you can make it with App Inventor, but you need to have a database. You need to look at database. I will not cover database today, but definitely you can make it with MIT App Inventor. But look at the database, how to make a database, because reservation system, you need to keep data, read back data, delete data, or process the data. So you need a database to do that. 8266 is very cheap. So that is one of the best advantage. This actually you can get for only 10 ringgit. You can get this device. And there are many variation of ESP8266. ESP01, ESP02, ESP03, ESP04, ESP05, ESP12, ESP12E. So there are many variation. All these have different size, different pin, and but all of them can use the same code. So that is one advantage that you can see there. And 8266, there are many sensors that is suitable for it. Although if you are using Arduino, 8266 most probably will be suitable, but please bear in mind this is 3.3 volt system. Arduino is a 5 volt system, so there might be some issues there, but all of it can be solved in a certain way. Okay, I'm taking some time to answer this, but I think it's important for us to answer these questions before we begin. For those who already have start beginning the tutorial, you can go ahead, but I'll keep answering this for now. Is tutorial about server and all applicable with ESP32? The same coding can be applied. Yes, ESP32 also will be the same. The code I think will be just slight different in the library, and that's all. When do we need to use Nodemcu as server and when should we not? Okay, this is a good question. When you want to use Nodemcu as server is when you want to have something to become a server to serve other stuff. For example, in this example, we want something to serve us with the sensor value, and we can send a sensor value to it, or we can read sensor value from it. It becomes the server or the place where we ask for the response. So in this example, I will use Nodemcu or ESP32 will become the server. So your mobile phone will become the client. And even in the same case here, you can have another Nodemcu to become the client to get data from the server, right? So client doesn't really serve anything. Client doesn't give any output. So the server is the one that gives the data. So the client can request for data or can send data, but the server is the one that process that data. So the client is the one that will request the data from the server. The server will respond, and the client the process that data. So it can be both client and server. Nodemcu can be both. In this case, you have two: one as a server, one as a client. Your computer can become a client also. Or in a case where you have a computer, for example, you want the computer to serve, to become the server. That is also possible. So the computer will become the server, then Nodemcu will become the client. The other laptop will become the client. The computer, Google, Amazon, and all those companies, they actually have a server somewhere in the world that is actually having all the code to serve you. So when you request www.google.com, it will give you the data in it. So that is essentially what a server is. So same way here, when we request from the sensor with certain instruction, it will respond to us with the data. So you can, some device can become a server, also a client. You just need to imagine the process that is going through. I don't recommend you to do simulation first with Proteus if your circuit is not complex, because you don't have enough time to do that. Because you have a lot of people in your team. If someone want to focus on simulation, that's fine. But I think proceed with the hardware stuff, because it might take time for your system. If you have any problem trying to figure out whether this is possible, this is not possible, you can always contact me. I'll just give you a quick answer. Okay, this you can do. You can purchase the device and you can just do it, because you only have I don't know, you only have 8 weeks to do this. That is not a long time. Yes, resistance definitely. Actually, a sensor, also some sensor are resistance based. So if the sensor is a resistance based sensor, then whatever change in the resistance, the Nodemcu can detect. So this is definitely something possible. You can definitely read the resistance value, because you can read analog value. You just do the analog reading and then convert that back to resistance. Mathematical operation, definitely ESP8266 actually is faster, if I'm not mistaken, from Arduino. And if you use ESP32, it's much faster than Arduino. I think 10 times faster than Arduino to do calculation. Okay, this one I will do the explanation later on. Also, sorry, which port is analog or digital? Okay. Many of the port in ESP32 can be used as analog or digital, but there are pins that can do analog only, but most pin can do digital, but some pin can do analog. You need to check, just check online, analog pin for ESP32. That's very straightforward. Yes, you can do RS485 converter using Nodemcu. It is quite challenging. You might need some extra hardware in order to do that. I think this one, there's a lot of tutorial online. You can look for that. Nodemcu ESP8266 can connect directly to a relay, but it will give you 3.3 volt. You need to find a special relay that can that can support this. In many digital system, they whatever that is above 3.0 volt, they will consider high. Whatever that is lower than 3.0 volt or sometimes 2.7 volt, they will consider low. So if this is the case, this can match the 5 volt relay, because in a 5 volt relay, I think same above certain value, maybe 2 point something, it will consider as high. Below 2 point something is considered as low. I have used ESP8266 with a relay before. Some relay work, some relay don't work. So you need to make sure the one that you use can support 3.3 volt. Okay, that's all. Yes, definitely. There are a lot of tutorial out there. But this one says, can I use Arduino connected to temperature sensor, pulse rate sensor? Yes, you can use Arduino, but Arduino, if you don't buy the correct one, most Arduino cannot communicate to the internet. It is not an IoT device because it only can read sensor, then process sensor, and that's it. Finish. But if you use ESP32, you can do the same thing that you can do with Arduino, but you can have the Wi-Fi function, or even ESP8266. But all this can be done with all three except Wi-Fi, Bluetooth. You need to choose the right one. Okay, Nodemcu 8266 have many version. There's only, I think, 3 version. By the latest version, the only difference is they upgrade some component on the version to make it better. So the highest version that you get, the better. This is talking about Nodemcu, because ESP8266 also have many other version. They have ESP01, they have ESP02. So all these have a different pins actually. So it depends on your function, how many pins you want to use, how big you want your controller to be. That one can be done with this. But for Nodemcu, if you're talking about Nodemcu, then I say buy the latest version that you can, because they upgrade. Once they found there's a problem with the previous version, they upgrade, then they release a new version. 5 volt relay, yes, ESP32 can be powered by a 5 volt relay. There's a V-in pin on the 5 volt relay. On the ESP32. That pin is especially for putting in 5 volt to turn on the ESP32. But I'm not sure why do you want to power ESP32 with the relay. That one I'm not sure why, because usually you don't need to. Maybe later you can share why you need to do that. But yes, you can power using ESP32 using a 5 volt relay. For to be used as database, you can check Firebase. I think that is probably the free version that I think there are a lot of tutorial. This is from Google. And MIT App Inventor also support this. Okay, so you can check that one. Firebase, it's called Firebase. Yes, ESP32, like I said just now, I already answered this one. I think not MCU can do Wi-Fi straight away. So you can communicate with the internet straight away. If you're using Arduino board, you can only communicate with the sensor. You can read temperature sensor, you can read color sensor, you can read this sensor, that sensor, but you can only work there. You cannot communicate with your phone unless you have another module installed, a Wi-Fi module or a Bluetooth module. For ESP3266 already integrated the Wi-Fi module. What is good about that is you don't have to worry about the connection, the programming to program the Wi-Fi. All that is being done for you for ESP8266. Even ESP32 is much easier for you to use this function. You don't need, for example, Arduino board, if you want to make Bluetooth, you have to put HC05 Bluetooth module. But you still need to make sure the connection is okay, the coding is okay in order for you to make this work. But for ESP32 already integrated, so you just need to be worried about the coding. And once you got the coding done, you don't need to worry about the hardware at all because it's all integrated. It should work as it is. Do you recommend using LabVIEW to program Arduino? Yes, you can use LabVIEW to program Arduino. There are some advantage. It depends on your application actually. LabVIEW is a very strong, powerful controller. It's like MATLAB. It's an analysis tool. So for example, you want to do face recognition. You cannot do that with Arduino. Arduino don't have that power, but LabVIEW can do face recognition. Or maybe you want to process a lot of data. So Arduino will take a lot of time if you want to process a lot of data. You process that with LabVIEW. When you want to turn on some sensors or some actuators or read some sensors, then you can read from the Arduino. That is possible. And I think the application is different. If you want simple stuff, then you should just use Arduino. You don't need to use LabVIEW. But if you want to process more complicated stuff, you need to go to LabVIEW to do the processing. If the PWM pin enough, if I direct use Nodemcu as my main board, if I need to connect to 4 motors with 2 motor driver, yes, this is enough. You just need 4 pin for motor driver. One motor driver, you need 2 pin. So if you want to control 2 motor driver, 4 motor. So one motor 2 pin. So if you have 4 motor, you only need 8 pin. You only need 8 pin. So not MCU, I think I have enough pin. I have more than 8 pin definitely. And all of these are digital, so should be okay. Yes. So these are questions that I think is important for everybody to understand. Everybody heard about Arduino, everybody familiar with Arduino, but suddenly you heard not MCU. Actually, it's the same thing, but it's from different company. You can imagine Samsung selling a phone, right? Samsung have their phone, Android, and Apple have their phone. Apple have their phone, and this Android iOS, this one use Android, and they have some functions similar, some function difference. So same here, you have not MCU. This is from a company called Espressif. Arduino is from a company, I don't remember, I don't know which company, but it's from another company. So both of them make microcontroller. So Arduino make controller a certain way. Espressif make controller certain way. So some advantage on the others. Some Arduino have advantage. Some ESP8266 have advantage. So same as if you have Samsung and Apple phone. Both can do the same thing essentially, but there's something extra about each board. And my advice is, if you need to use only one, then just use one. You don't need to use both. You don't need to communicate between both. Just use one for the same purpose. Whatever Arduino can do, ESP8266 can do. And same way, whatever 8266 can do, Arduino can do, except for wireless. Wi-Fi, ESP8266 already have the function available. Oh, okay. Yes. Some design requires you to convert between 3.3 volt to 5 volt. There is an IO converter, very cheap, around 3 ringgit, I think, or 4 ringgit, if I'm not mistaken. But what the board does is it convert from 3 volt to 5 volt, or if 5 volt from here, it convert to 3 volt. So there is a board that can do that. Basically, oh sorry, you can search level changer, level module or something, level. You can search 3.3 5 volt level module. Then you'll find the board that I'm talking about. Analog pin. There's a lot of analog pin actually on ESP8266. So you can just search. Mana pula ni? Let me go very quickly. Oh, sorry, I forgot. For ESP8266, you only have one pin. So maybe you want to consider using ESP32. ESP32 has many pins. I think for you, just better change to ESP32 if you need more pin. ESP32 have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 analog pin. So if you need more, then you can go for ESP32. Okay. Alamak. Kenapa dah tak boleh tekan ni? Bukan ni. Oh, present lah, silap. Okay. Alamak. Ni belum masuk tutorial lagi. Tak sempat nanti. Okay, only 43 questions. Okay, this one use ASP32. This one is a problem with MIT App Inventor, I think. But I think I have used some that solve the problem. You can also use Tankable. There's another one. Tankable.com. This one support iOS and also Android. Supports both. Essentially, it's the same thing with some a little difference. But I think multiple page app should be no problem with MIT App Inventor. And Bluetooth, I think maybe the way that you make this Bluetooth is making it a problem. But I have used Bluetooth before and it should be okay. This one I have answered before. This one I have answered before. This one I answered before. Why is all the same question? Oh, okay. No, after you upload, it will straight away run. So there must be something wrong with the setup. One thing that I can think of straight away is the pin number. The pin number needs to be correct. Also, another one, you need to have pin mode to make sure it becomes an output. Pin mode, whatever pin you are using to output. This is a must. Okay. Compile the code setup for ESP32. What do we need to do at the module? You don't need to do anything. Actually, after you upload, straight away it will blink. If your code is correct. If your code is incorrect, then there is something wrong. I will show you on my board soon, and we can see. No, not MCU. There are many that are doing simulation for Arduino, but not MCU. But if you want to check Arduino, the code is similar. You can check Tinkercad. Tinkercad.com, if I'm not mistaken, or .io. But I think because it's so cheap, you don't need to do simulation you can just buy and test it online in real life. Is powerful enough to support tiny machine learning for embedded system. I'm not sure about tiny ML. I've never heard of this tiny ML thing, but it is quite strong. ESP32 is quite strong. Not MCU, definitely not. ESP32 is quite strong, and it can support face recognition. It can support some simple recognition. It's possible to do it with ESP32. I think ESP32 is a good choice if you want to do this machine learning for embedded system. But I'm not familiar with TinyML at all. Usually I use a Raspberry Pi if I want to do machine learning stuff. No, there is no way to connect ESP32 directly to UTM Wi-Fi because it is using Capstone portal. But if you just want to communicate inside UTM, it is okay. You don't need to go to the Capstone portal because whenever you connect to the UTM Wi-Fi, it automatically connect to the local network. You can communicate in between the sorry. Oh no, cannot because you cannot log in. Only local you can. So maybe if you want to do some example, you can do local host only on your computer. Your phone will become the hotspot. Then you can use that. You can use your phone as hotspot. You can use your phone as hotspot, but not with UTM Wi-Fi. This one I don't understand, but basically this one is your design. You as a designer, you have to decide. You decide the end goal. You decide you want many sensor, you want one relay. That's okay. You want many sensor, you want many relay. That's okay too, because it's up to you. You need to understand the concept why you want to use sensor, why you want to use relay. So if you want to use sensor to turn on the relay, and you want each sensor to have one relay, then you make it like that because you are the designer. You will design around the Nodemcu and ESP of what you want to do. Okay, the last question. Can ESP be controlled without the need of Arduino, like upload the code on ESP to run using the app? This one I don't understand the questions. Maybe about Arduino IDE. Basically, the code will decide what happened with the ESP. So you have to design the code to work as how you want the code to work. The example that I use today will not be probably will not be the same as what you want, but you have to design. You have to use the code that is available. You have to tune it. You have to change it, modify, so that it works like you want. Upload the code on ESP to run using the app. Yeah, we will upload the code to ESP using Arduino IDE, then we will run using the app. Yes. Okay, 45 questions. I think I will stop there for the question, but you can keep the question coming while we go for this. Okay, I hope many of you have done this. It's already 3 o'clock, but we will do this together. But the way I will do this, I will just tell you which part of the code that you will do. So for now, I want everyone just to do from page 8 to page 16 or 17. Okay, do page 8 to page 17 first. If you can do all, that's okay. I will explain what is happening inside the code here so that you understand what is actually happening inside the code. But I think I want to open if anyone have any question. If you have done this page between 8 and 17 and you have any problem, let me know. I will mainly try to troubleshoot with you instead of telling you do this, do this, do this. I will tell you briefly though, what you are doing now. Here you are installing the ASP8266 library. So you can use the board of ESP8266. If you try to find ESP8266 on your tools and you cannot find it, that means you haven't installed yet. You have to install this first. And then only you can upload to SP8266. If not, you cannot upload to SP8266. And then you can take the code. Here is what I meant. If you cannot select this, if you are using ESP32, then you just choose ESP32, just choose ESP32. And for the code, just change here, include ESP8266 Wi-Fi to include many of you asked just now, so here you want to do Wi-Fi .h. This one is for ESP32. This is for ESP32. Wi-Fi W capital, F capital, I small, I small. Need to follow that, otherwise it will give you error. Wi-Fi like this. Just remove this if you are using ESP32. That is the only difference in this code. There is a link here also in the notes. And then you can after you have upload this, you want to check if you can communicate with the device. You need to go to serial monitor and check the IP address. This is the IP address I was talking before. You remember when I talked about Google, they have the IP address. When we type the address, actually we are going to that address. So this is the address of your server. This is the address of your Nodemcu or your ESP32. So now it becomes a server. It has an address. We as client, we just type the address and the server will give us what we want, what we need from the server. Okay, I will let you try this until page 17 for a few minutes. For those who have tried, please let me know what are your problems so I can troubleshoot together. I think this one I prefer if you can talk, so it's easier for me to ask what was the problem. Anyone have any questions first before we move on? Anyone have tried this?
Doctor, I have questions.
Okay.
Is IP address generated by Nodemcu is generated in random way, or is it there's a syntax?
It is random in a sense. 192.168 is standard, but the back one is actually depend on your router. The router is the one that give you this address, not the Nodemcu. Nodemcu doesn't create this address. If you connect to a mobile hotspot, the number will be different. If you connect to a UTM hotspot, it will be different. If you connect to your Unify hotspot, the number will be different. So it's not up to the Nodemcu, but it's up to the router that you connect to. The DHCP router. Okay? Boleh siapa tu? Ziad
Thank you, Doctor.
Okay, anyone else have any questions? Any problem uploading? Please let me know. If you have, I can just answer it very quickly here before I explain what the code is all about. Maybe I'll give maybe 2-3 minutes for you to start to do this first. It's quite easy though, because I already give the code. Otherwise, if we write the code here, I don't think we'll have enough time.
Doctor,
Yes.
in my system, it shows the selected serial port does not exist or your board is not connected.
Okay, so that means your USB and the computer is not communicating properly. The first thing you want to try is unplug. And when you plug, do you hear a sound?
Arduino.
No. Do you hear a sound? When you connect. You know when you connect Bluetooth. Let me try connect mine. If there's a sound for mine. Tak ada bunyi pula. Does yours have a sound when you connect to show that there is a connection?
Between computer and Arduino board.
Yeah.
Okay, let me check.
Just unplug and plug and hear if there's a sound.
Okay.
If not, you go to here, device manager. You go to device manager, you check if there's any unknown device. You should have something like this. USB serial CH340, or if you use a different one, CP2102, or if you don't have this, if it says there's some issues with the board, then you need a driver. You need to install the driver. The driver you can download actually from driver CH340 driver. You can just download from here. If you check device manager and you have a board that is not installed, then you need to install this. I will share it on WebEx. Mana dia share chat. Okay, ada ni. Yes, good. Thank you, Moment. The cable also need to be correct. Cable needs to be cable needs to be data cable. Cannot be charging cable only. If you connect and you don't hear any sound, then that must mean that you have a data cable. Sorry, charging cable. Yes. Thank you, Moment. Any other questions? Before I explain the code. Everyone can follow the tutorial. Can I see a reaction? If you can see, if you can do the tutorial properly, so I know how many of you are able to do this. I'm making this more like a question answer session because I don't want this to be like a tutorial like online, because you won't get any much benefit. But if you try to upload and you have any problem, usually they don't tell that you on online, because they have solved that problem already. So here is the chance for you to ask questions, for the chance for you to really ask direct questions if you have any, like the cable issue. Yeah, definitely. Yes.
Doctor,
Yes.
I've uploaded, but the serial monitor just showing dots coming out. What seems to be the problem?
Okay. So you can see in the code here, this is the dot you are mentioning. So it's trying to connect to your Wi-Fi, but it cannot connect to your Wi-Fi. Either your username and password is wrong, either it cannot detect the Wi-Fi too far. It's problem with the Wi-Fi. My advice is try to check the spelling of your Wi-Fi, make sure it's exactly the same. And you cannot use UTM Wi-Fi. It cannot connect to UTM Wi-Fi because it will have it will ask for the username and password for the student. So you cannot enter that in not MCU. So that's why it's trying to connect and you cannot connect. So you need to use your own apa nama tu hotspot on your phone.
All right. Thank you.
Yes.
How do we know if how do we confirm the port that we connected? I'm not sure that.
Okay, so the way that you do this is like this. You see my port here? My port pula. My board here.
Yes.
You can check here, tools, port. Okay, now you see two port, right?
Yes.
COM1 and COM6. So if I remove this, now you should not see one. Alamak. My mouse dah rosak. Can everyone still hear me? Yes. My face also dah hang lah. But hello.
Hello,
Yes,
Doctor, we can
we can
still.
hear you.
dengar. Okay. Sekejap Okay. So now if you check here, you only have one port, COM1, right? So you know that your port that you unplugged just now is COM6. So I plug this again. I think my face is gone now. Because cabut tadi tu dia pening sikit lah kalau ada cabut USB. So I think no more face lah. Only my voice now. Hey, okay, it's back. Okay, any other questions? Before I start sharing with you the code. Okay, I will probably just share the code now, and if you have any question, you can ask on the chat, and also if you have any question about this later, you can ask on the chat. Not on the chat. Don't ask on the chat. I think better ask on the list. It's much easier for me to track the question. Okay. Let's go to the code. So if you are using ESP32, you just include wi-fi.h. So that is the difference. But I'm not using this, so I will comment out this. So ESP32, you can make this. This is the library that you will call in order to do the Wi-Fi thing. This is your hotspot. So for example, let me turn on my hotspot of my phone. I'll have this. Okay. That is your hotspot SSID and password. Why do you need to put it here? Because your Nodemcu or your ESP32 wants to connect to the internet. So it will use this to connect to the internet, and it will make itself as a server. This is where it says I will be a server, Wi-Fi server, and my port is port 80. It will use port 80 because there's a lot of different port. We will use port 80. And these are just declaration of some values. Declaration for some values. We have the header that we want to send for the HTTP request. We have output state of off. We have the output pin 2 and input pin A0. We have also update sensor value of 0. These are just a variable that we want to use later on. We just declare them. And this is the time that this is for the timer. So millis give you the time, the current time.
Sorry.
Yes.
Can you zoom in a bit, the code? Because it's a bit...
Okay. Okay?
Oh, yeah.
Okay. Okay, so millis is actually talking about giving you the time, the current time in millisecond. So we will use this as a timer to check for 2000 millisecond. If 2000 millisecond have passed, then we will start processing. This code we will see again at the end of the loop, in the loop function. This is only the declaration of the value. So if you want to change your timer to become 10 millisecond, you can use 10,000 instead of 10,000 here, 10,000 here. If you want 10 millisecond, if you want 1 millisecond, 10 second, 10,000 millisecond. If you want 1 second, then you put 1,000. That is 1 second. Okay, let's go next. Now we come to void setup. Okay, in void setup, it is where we set up stuff. You can see that the code is you're following the Arduino code, right? So it has void setup and void loop. Somebody asked just now one more question to test the Nodemcu, void setup not included. In this code, all need to be included. Void setup there should be a void setup and void loop for all code in Arduino or for ESP32 and ESP8266. Okay, let's go through this part of the code. This is where we want to start the serial port. When you want to do serial monitor, if you don't initialize this, then you cannot use the serial monitor. This one I set the output pin. I have set this to pin 2 and this one to pin A0, A0 just now. So you remember the one that a variable that we see up there. So this one we want to set as output. This one we want to set as input. So this is actually pin 2 and pin A0. And I digital write output high so that pin 2 will become, an LED will become off. In ASP32 and some board, when you give low, LED on. When you give high, LED off. This is because of the connection of the circuit. So if your circuit connect it to be active high, then you send high. If it's active low, you send low in order to get it on. So that is this is just to turn off for a while during initial start. Then this part here is where you want to connect to the Wi-Fi that you have set just now. If the dot keeps coming, then your Nodemcu is having trouble connecting to the Wi-Fi. So you should find out what is the problem with the Wi-Fi. After it successfully connect, it will print the Wi-Fi connected. It will print IP address and the IP address, and it will print this to show in the serial monitor. So this actually only is initialization of port and also init Wi-Fi. Just to turn on Wi-Fi, make sure Wi-Fi is working, then it will go. If Wi-Fi is not working, it will not go anywhere. It will just stuck there. So you will not see the bottom part here because the Wi-Fi is not connected. Okay. Next, if you have any question anywhere, just stop me. Then I will answer you straight away over there. Okay. Now we are in void loop. Okay. Now we are in void loop. You see that we have start turning on the server. So this is for Wi-Fi client. You are not client. You are server. The client is the one that will come to get the data from the Nodemcu. It can be a website. It can be a browser. It can be mobile apps. It can be another Nodemcu. So anyone that is a client can come and get data from this server. So when the client, if there is a client connected, if client is connected, then start counting the data. Start counting the time, and if the time is 2 seconds, in between 2 seconds, I will not explain in detail, but this is actually to detect that 2 seconds, the 2000 that we have up there has elapsed. Once the 2000 have elapsed, then you start doing stuff. Otherwise, you just ignore this. So this will only be done every 2 seconds in case of this code, every 2 seconds. Okay, so what will happen every 2 seconds when the client is connected, the client is requesting for data? What will happen is it will read the value that the client is requesting. This is the request from the client. Okay, this is the request from the client. Let me just clarify. Oh, this is to collect the information that you want to send back actually. So you can see here, this is the format for HTTP, the format of the response that we want to send. So this is the response that we want to send to the client. Whenever the client requests connected, then we will send this. We send this first. So client print is all the thing that you want to send. to the client. So for example, here we print all this. We say that HTTP 200 means okay. What is the content? It will be HTML. Then the connection will be closed. But then it will send here. You can see here, if header index of get LED on, this is the HTTP request by the client. So the client is requesting a get HTTP request, a get HTTP request. And in that get request, this is the instruction in the get request. For example, 192. Okay, I will probably upload this and give you an example. This is correct. Yep. Okay, upload. Okay, I will upload this first to my board. Okay, please make sure everyone have reached the page 16, because after we're done with this, I'm going to go straight with okay, code wrong. Not sure where when I did that. Whenever, if you have any problem you want to ask, you can. Ni ada error.
Doctor, I asked the question in the chat box.
Okay. This is still error connecting to your bot, not MCU. Apa nama ni? So, do you see the word connecting, Zakaria?
Which one, doctor?
Here, do you see the word connecting?
Yeah, connecting COM6.
No, the connecting word here when you upload. Do you see it? Wait, let me finish mine first. Okay. Do you see this word here connecting on the orange color? This one. Does
Yes,
yours have a long connecting?
Yes, doctor. Yes.
So what this means is it's trying to connect to your board, but it cannot connect. So one way to do it is if you see on your.
It goes long way, but no connect.
It's trying to connect, but it cannot. So if you see on the ESP board, there is two buttons. One called flash, one called reset. Do you see it?
Yes, doctor. Yes.
So when it says connecting, you press the flash button a long time until it upload.
So I need to press and hold or just
Press
pressing?
and hold. Press and hold.
Okay.
After it start uploading, you can quit that.
Okay.
Okay. You see this one is the same as the one just now. Who has problem connecting? This one because my hotspot is not turning on. So let me turn on my hotspot. ESP32 pun sama. Aiman, there's a one button called boot. B-O-O-T. Okay, I just turned on my hotspot. Now I got this address. So let me show you what is get request. Now I'm trying to connect from my laptop to the board, but I think it cannot connect because my computer use a different Wi-Fi. My computer use my home Wi-Fi. I cannot share lah. Can somebody share very quickly the screen if you have successfully got the file? Because I cannot connect to this. My computer cannot do Wi-Fi now. My computer can only do local network cable.
Doctor, same error for me.
Does it stop when you press the button?
I press and hold the button and I release the button, but it shows the same error.
When did you press the button?
Before uploading.
No, cannot. You have to press the button when you see the word connecting.
Okay.
Only when you see the word connecting, you press the button.
Okay.
Anyone can share that if you are successfully connected to your LED? Can somebody share their screen? Ke semua tak jadi lagi? Anyone successfully connect to the IP address? Can just share the screen. I just want to use as an example. We have 150 participants. Hopefully one of you can get it done. Anyone? I need a volunteer. Just share your screen. I would explain from your screen.
The success connecting ada tak?
Aha.
Yes.
And dah boleh type IP address tu boleh type dah. Dah connect. Dah connect. Dah tulis tak? Dia tulis IP address.
Yang warna orange kat bawah tu ada. Ya lah itu tau.
Oh, bukan. Yang ni.
Oh, yang tu belum ada.
Yang ni. Dapat tak IP address ni?
Well.
Ni belum. Tapi yang ni dah sampai habis awak punya ni. Sampai living hard reset dah.
Ada.
Dah. Ni dah okey dah ni rasanya. Bolehlah share awak punya screen. Saya guide sikit. For everyone.
Oh. Tapi saya belum kena hardware ke tak? Saya belum kena LED ke apa kat
Tak payah.
SP30 tu. Tak
payah. Awak SP32 ke?
Ya tak.
Okey lah, tak apalah, boleh tunjuk. Saya nak tengok dia punya ni je. Browser je. Okay, thank you Faris. Okay, so Faris can click the serial monitor first. Serial monitor. Ni. Oh, tak connect lah awak punya ni. Ni wifi ni. Your home have wifi or not? Try press reset. Just press reset on the ESP32. Press reset je. There's a button called reset.
Boot. Reset
tak. Dah ada. Oh, sorry. Not reset. EN.
Oh, yeah. Tekan je.
Tekan je.
Sekali. Belum kena lagi tak?
Your internet ni is correct spelling?
Ya tak.
This means that it's not connecting ni to the Wi-Fi.
Okay, saya cuba lagi dah.
That's weird. There are some tips. If your Wi-Fi has apostrophe, you cannot use apostrophe. It will not identify that. Ada tak siapa dah percaya? Jason ni boleh Jason? Islam? Are you successful? I want to show the link je.
I'm at TCM. I cannot use the Wi-Fi here.
Oh, okay. In the lab?
Yes.
Okay. I hope there are some that is successful. But if not, I will just type here. Let me share my screen first. Okay. So when you type your IP address like this, when you press the button, you should get something like that. But I cannot connect now to my device because I'm using a different hardware, a different network. So supposedly it will be like this. The instruction that is sent to the Nodemcu. So this is my computer trying to connect to this address and trying to give this address this instruction. But,
Saya punya dah boleh tak?
Dah boleh dah? Okay.
Ada.
Cuba. Share. Okay. So you copy that address 192. Paste on a browser. Computer ni connect dengan same Wi-Fi ke? Try dulu lah, enter dulu. Enter. So this is what the Nodemcu actually is serving. The Nodemcu now is giving you the response of all this. So can you please press on? On. On. So when you press on, you notice on the address bar, can you go on the address bar, your mouse? Address bar tu, 192, tak, atas ni je. The not secure tu. So the address bar, you can see it says LED/on, which means it's sending this information LED on to turn on the LED. So this one actually is for the LED on your Nodemcu should turn on and off. Do you get that? Siapa ni, Faris?
Okay.
Berklik tak?
Faham.
Berklik tak awak punya ni? Nodemcu.
Dekat board tu ke? Dia berkelip.
Okay.
Dia tutup buka.
Okay. So when you press on, it should turn on the LED. When you press off, it will turn off the LED. So let me share my screen now. Faris, thank you very much, Faris. So you can see the pattern is actually here. This is what we are looking for, and this is the important part. If you want to make for your device, this is the part where you want to change. You see here, LED on. What will happen if the client asks for LED on? It will digital write output low. So it will turn on the LED if the client set this. If the client set this, it will turn the LED off. And if the client set this, it will read analog value and update the value on update sensor. So you can actually have more of this thing. What is the instruction you want to give, and what is the instruction that you want to send to the hardware here? You can see these are all just get instruction. So from here to here, these are all the instruction that you can do. You can put more if you want. For example, if you said when the server receive LED on, you want to turn on LED, you want to turn on relay, make another code for turn on relay. You want to turn on apa lagi yang boleh turn on? RGB LED. You want to turn the RGB color to red. You want to move the motor. All that you can put whenever you receive the instruction, then put everything here of the instruction that you want to tell to the actuator. In my case, in the case that I have here, I only turn on the LED. So the LED will turn on. Like I said, this low is on because it is active low. Okay, so this is what will happen, and what will be shown on the screen is actually this one. All this client print is actually the data that is sent back to the server, to the client with all the information here. So this is the button. This is all HTML actually, HTML. So the top part here, I think you don't change, but if you want to change, you can change the one that is here or here, because this is actually the one that we have here. So this is ESP web server. So this is ESP web server. GPIO2 state. That is actually here, GPIO2 state off. And I go back here. Mana dia? Now LED on or LED off. If output state is off, then display this one. If output state is else, then display this button. So that's why you see one is button on, one is button off. So this is actually what the server is serving to the client. Okay, and I think that is all. These are all just format to close the body, to close the client, and that's it. That is all the code. So not so complex. You see a lot, but actually initialize Wi-Fi, initialize port, then serve the client. This is all to serve the client. It will serve the client. If it receive LED on, do something. If it receive LED off, do something. If it receive sensor read, then do something else. You can put get do something else, do something else. So you can have 10, 20 sensor. It depends on your pin here. And you say here, I said digital write output low, right? But if you have two sensor, for example, or if you, sorry, this is not sensor, this is actuator. But if you have two sensor, you want to read two sensor, you can have update sensor 2 equals digital read, maybe. This is sensor 2, input 2. So you can have many more sensor. Depends on how many sensor you want. If you want 10, 20 sensor, then you need to pin, connect that to your pin. Then you can just do a lot of this. And then what do you want to do with this data? You can process the data. If the data is higher than certain number, turn on the motor. If the data is too low, then turn off the motor. Things like that can be done here. Okay, I think that is all on the server. Now we have our server ready. Our server is ready to receive instruction, right? Okay. Any question before I move on? We don't have much time left, but I think we can. I'll try to finish in 30 minutes. Then I'll answer some more questions, I think. Any more questions from anyone? If you have any trouble, just write it down. I will monitor that. Yeah. Oh yeah. 5G also cannot. Yeah, definitely. Thank you. 5G cannot. Need to be 2.4G. If not connecting, you press boot. EN is for resetting. Boot is for uploading when you want to upload. Okay. Okay. Thank you, Anis. Wo Shin Yu and Liu Jinho. Yeah, you are correct. I cannot use 5G. If your Uni 5 is 5G, you need to connect to the other one that is 2.4G only. Okay, I think some of you probably have managed to do this. I will not look at the question yet, otherwise might not have enough time. Now, everyone can go to notes page 19 to 37. Okay, 237. 237. I will do this together with you very quickly. I will do this with you. So create apps. And some of you might think App Inventor is not a very good apps because of the look of it. It's very simple, but actually you can make quite complex app with this. Oh, actually I'm done here, but I think I'll make another one. I have some apps. I use Mqtt App Inventor. It is in App Store now or Play Store. I also have apps that is make using Tankable that is already in Play Store and also App Store. So it is possible to make apps that is so I'm making another apa nama ni? I'm making another apps. So App Inventor is very easy to use because it uses drag and drop. So you can see on the left here, you have all the function that is available, and user interface is the top one. So you start usually with the GUI when you want to do stuff. So for example, button, I have a little bit of text. I have I think I'll just put 2 buttons straight away. Or 3 buttons straight away. So I can edit the button, or actually I want to make the screen center first. And mana pula center ni? Center, horizontal center. So it become at the center. So now I can edit all this. ESP controller. Then the first button I want to use for turn on. The second button I want to use for off. The third button I want to use for voice. And I have another label for sensor value. Then another label for the value itself, which is I will put as 0 for now. Okay, and you can play around a lot with this. You can have a special background color. You can have a background image. I'll just put some background color lah. You can make it look nicer or not nice, up to you. There are many more tips. You can make this wider. You can use image as button, and there are so many, but I'm just showing you the basics today. For those who ask about database just now, you can actually do connectivity. You can do, wrong. Experimental lah. Firebase DB. You can use Firebase DB. Okay, now we have done the GUI, the front page. We also need to add some function to this, a web function. I'll add to this because I want to send the get HTTP request. I will use also speech recognizer because I want to do speech recognition. So these are all that I need. Now I will go to the code. So the code is empty now. So this is the GUI, the one that you design in the front page. And this one is the code. What will happen when you do stuff in the front page? For example, you press the button 1. Button 1, what is button 1? Button 1 is on. It's state here on. So what happened when we press button 1? What information do we want to send to the Nodemcu? Anybody knows? What information do we want to send to Nodemcu? Anybody can guess? To turn on the LED. Okay, good. Ko Chiyong says LED on. Yes. Now we want to send the get HTTP request. We go to web. We said we want to send get, but we don't have the address yet. So we go to web again. We want to set the address. Oh, wrong. Wrong. Not this one. We want to set the address. We don't want to get the address. We want to set the address, the URL. Set it to what? Oh, sorry, I forgot. Tak apa. I'll just do this for now. Okay. How do we want to? Okay, how do we want to turn it on? Kachiyong said LED on, but we actually need to have the address, right? 192.168.42.12 maybe. Then you want to have LED on. I think it is important to have the letter correct. I'm not sure if it works without the letter correct. Okay. So just like this, you can now turn on your LED just by pressing the button. And when you want to turn off, what do we send if you want to turn off? Ko Chiyong, how do we turn off? Dah tak tahu dah. Okay, thank you. LED off, right? So we just send LED off. So this will turn off the LED straight away. that is enough code for you to turn on and off the LED. All right, the one that you get from the website is much more advanced than this. We take the value of this on a text box. But essentially, this is all you need to turn on the LED. And now you can actually build this, you can, for those who are using iPhone, you can do AI companion, I think. I cannot use emulator. I don't have the emulator, I think, on this computer. Tak ada emulator on this computer. But what you can do is you can do this, build Android APK. This is the installer file. This is like the exe setup.exe on your computer, but for Android. So once I done that, I should get a QR code that I can scan and install the app straight onto my phone. I think for now, I would like everyone to try this one. And I will give you a few minutes to follow the steps. This is actually the same steps on the notes until page. Until page 34 actually. Until page 34. Okay, I think we'll have a short break while waiting for those who are still doing it. You can have a short break until 4. I will maybe, while the others are doing it, until page 38, until page 38, I will try to answer some questions. Oh, ada sikit je lagi. Anybody who wants to ask question, you can ask.
Can I ask questions?
Yes, yes.
So let's say we have uploaded the code on ASP already.
Yes.
Does it have to be connected all the time to the Arduino software, or we can?
No. You can unplug it. You can plug it to the wall charger. It will still work because the code will be fixed in there. You can use power bank to power your ESP32. It will still work. It will connect to the Wi-Fi, but you cannot see the serial monitor because you are not connecting it. But it will still work.
I see. So after uploading, after connected to any supply, it will still run the same code. We don't need to press anything on the ASP. It just reads straight away to the same address.
Correct.
All right. Thank you, sir.
Okay. Anyone else have any questions? To the AC pin, unit 3. I cannot copy this. Boleh. Let me check. Oh no, this one is not. This is almost the same, I think. If you use ESP32, I think the analog out is only 2. So all ESP32 will only have 2. This one, I think it combined Arduino and ESP32. Oh no, this is still ESP32, only the different form factor. So if you want to use more analog out, there is a chip that you can use. I don't remember the chip name, but let me just search analog output. Why do you need so many analog output? Let me check. Digital computer. you can use analog output. There are many ways to do it. Maybe the I should search here lah, DAC. I think you can use this MCP 4725. You can use this to connect. You can use yeah, you can use this module to give output value. No, not this one. This one. DAC. You can search DAC. Siapa yang tanya tadi? Sini ni you can search DAC. Okay. Yes, you can use higher baud rate than 9600. But I don't see why, unless you are connecting to a special device that use a different baud rate. Some device is 57600, some device use 115.200. But if you just want to communicate with the computer, 9600 should be okay. Any more questions you want to write here? We have 5 more minutes before I go to the next session. And if you have any questions on the mobile apps also, please don't hesitate to ask. The one that we have here is a bit more complex, the one that I have. But if you follow this one, it should give you the same results. So you can follow until page 38. Yeah? Oh, ada lagi soalan ni? Boleh. If you want to use BLE, Mqtt Inventor without BLE connection loss. HC05 is not BLE. If you use ESP32, it will be BLE. It will be BLE. If you use HC05, it will just be Bluetooth 2.0. BLE is Bluetooth 4.0. It's more advanced. But okay, you can contact me. Just email me with the questions and can discuss, or you can come meet me during the Capstone time next week, next few weeks. The limitation of MIT apps. Okay, I can say here you can download the APK and you can install straight away on your phone. You can have the mobile app straight away on the phone. Unfortunately, I cannot show you on the phone. I was planning to show the mobile apps on the phone today, but the apps doesn't work. Let's View doesn't work on my phone today. I don't know why. But somebody asked just now, what is the limitation of MIT App Inventor? Actually, the limitation is because of this block. For example, for math, there are many more equations that we can do if you are using code base. If you don't need to use any more than this, then that's fine. But if you just need to use whatever that is available here, then that is okay. But if you need to not use more, then you need to use code base. Text also is another example. So these are the only function that is available. You cannot use any other function unless you make the function using the extension. So you are limited to whatever block that is available here. And these are not all the block that can be. There are many others that we can use actually, but you are now limited to this only. In terms of GUI, I think there is not much limitation in terms of your front page design, because the front page is only arrangement of image, colors, button, text. So any arrangement, you just need to be creative to make it beautiful. Anything that you can do with the normal coding, I think mainly you can do with this with some creativity. But in terms of the block inside here, you cannot change this so much. If you want to use some function, for example, replace, there is a replace, split ada, apa lagi ya? Apa ada tak apa? Uppercase ada. What else do I usually use? String replace, string concatenate ada. So banyak yang ada lah. But I have run into some cases where I feel, I need to use this function, but it's not here, so I cannot use the function. But it can do actually for you as student, I think it can do a lot already. It can do almost anything that you want. If you are very advanced, then you start thinking of going away from Mqtt Inventor because of the limitation. But for Capstone, definitely, I don't think you have enough time to do for something else. Mqtt Inventor is the fastest way if you want to develop a system, because for Capstone you need to do a lot of different things. You need to have sensor, you need to have controller, and you need to have mobile apps or system to control. So it's quite a lot. So for you to do coding, it will take time. It is definitely possible, but because you only want to spend certain number of time for your Capstone, certain amount of time, so you can spend the other time to develop, to finish the other project. In order to make the device stand alone, we would require to design a web page. Not really. Actually, the web page that I designed here, right? There is a web page here. So if I don't want to design this web page, it is also okay. You just cannot control it with the web, because when the client asks from the server, okay, I want something. So how does it ask for the server? It actually by writing down the IP address, for example, Amazon.com. By just doing this, you are actually already asking Amazon.com IP address. Okay, I need some info from you. Please send me the info. So this is from Amazon server. For in our case, this is our server. Whenever I request from this address, hold on, it's connecting, I think. Oh. Let me reset. Okay. So in our case, whenever I write the address here on the web page, it's actually trying to access Nodemcu and send some data to me. But in this case, it cannot lah. But if the one that can, it will give us the data. If you don't want it to give data, then that's fine. You can just keep the data not shown, but you can run the instruction like we did on Mqtt Inventor. So it will only send back data when it receives the instruction. For example, here, when it receives LED on, it will give some data. If it doesn't receive anything, then you don't serve anything. So it's up to your design of the web page. This web page that you see here, mana tadi, this web page that you see here, this is actually, the server is on the Nodemcu. It's not on a computer. That is the server that is serving that page. Embedding the URL. Who is asking this? May I know what you mean by this? Can the one who asked this ask this so I can answer properly? Siapa ni? Cepat. Who is this? It's okay. I just want to answer this correctly. You don't have to be worried about you asking the wrong question or what, because I'm not understanding this correctly, I think.
Doctor, sorry, I was asking the question just now.
Okay.
So because as you mentioned just now, so as I see in the slides, so we would require to embed a URL to to have a web link for in order for the MIT Inventor to be working, right?
Okay.
Like the button. So I was puzzled that what is the main function of embedding the URL? So since we are able to just use the web page, so why wouldn't we just use the web page?
Okay. Now I understand the question. Yes, you can actually use the web page directly, but in some cases, we want to use mobile apps to send instruction. For example, you want this instruction, you don't want a button for this instruction. You want it to be automatic, for example, and your apps doesn't really show a button like this. Your apps just keep reading sensor, and when the sensor value is certain, then automatically it send the apa nama? It automatically will send this instruction here. You understand or not? Because if you use a web page, you have to click the button, right? You cannot not click the button. If you want to turn on, you have to click the button. But if you want to automatically send this information, for example, you have a sensor, light sensor. When the light sensor is below 300, you want to turn on the motor, for example, the LED. So if we have to use the web page, then we have to go check the sensor value. Okay, now it's below 10. Okay, press the button. You press the button yourself. But if you want to do that automatically, then you can just send this instruction. So this doesn't have to be a button here in the front. You understand?
Oh, get it now. Thank you, Doctor.
Okay. Okay. I think I have to go forward. There is some more question tadi. Mana? Oh, here. There's 2 more questions, but I think I'll wait until I finish the rest of the thing. So now what we have done is we can now control this with our phone, right? I will probably not be able to finish all, but I will see how far we can go. Now we can control this on our phone by putting in the IP address, which is the location of our server, the Nodemcu, and by sending this instruction, LED on or LED off. Now what we can do if we want to take a value of a sensor. If you want to take a value of a sensor, for example, in this example, I use a line sensor. You can use anything analog. Actually, if you want to use digital, also just change the code to digital. But in this example, it will be an analog sensor. And you can see here, we put 2 more button labels to show the sensor value. And we use a timer. Okay, this is the timer yang somebody asked just now. If you want to wait 24 hours, I think, I don't know if you can add days. Ni boleh ni days? Add days. You can wait days even. You can have a clock timer. So what the clock timer is, it will wait certain value, maybe 2 seconds, then do the function. For example, in this example, I will wait for the timer to run. When the timer run, I will send this instruction. which is sensor read. If you remember in our code just now, we have sensor read is to get the analog read value. If you want to have digital read value, just put digital here. Or you can put one more of this, else if. Sensor read D, for example. This one is digital read. This one is analog read. For example. So this is a clock timer that will, whenever the time comes, it will straight away call this function. So it will update the value on the screen. So when we got the text, when we got the response from the server will send us a lot of stuff. So we have to filter it out. When we filter this out, actually here is why we filter this out. This one is only to check if the data is 200. 200 means there is no error. And then we will set the label text to the response content length 3. The start is 589 because I have calculated this. This is not the right way to do if you want to do, but I just want to show you how it is done. So when you have a different text, then you have to modify this number in order to match your needs. So this is to get the data, the digital value data, same way, but now you can get the sensor value of 102 when you run this program because it will keep reading the value every 2 seconds, if I'm not mistaken. And you can set that second in here. Here. Timer interval 3000. Meaning it will run every 3000. If you want to wait 1 day, then you can wait 1 day, and whatever you want to do after 1 day, you can put in there. Okay. Okay. Any questions up till here? I think I'll just finish this explanation. You probably can use this, you can run this later on your own time, but let me just explain the function here. The next one, if you want to use voice recognition, okay, we add one more button here, voice command. And then when we click that button, we call speech recognizer so that we can start recognizing our voice. And whenever speech recognizer get text, whatever we speak, then we do something with that information. What do we do with the information? We compare the information with the text that we want. For example, if somebody say turn on LED or turn off LED from the speech recognition, we speak turn off LED, then it get this result. So whatever is in here, it will do. This top one, it will call LED on. The bottom one, it will call LED off. This means that you can now turn on and off your device just by using your voice. You just click voice command, you say something, and you will be able to turn on your LED either on or off. Okay. I think this tutorial is very detailed enough for you to follow one by one until you get to the end. But what is not available in this tutorial is the problem that you will run through. So you might still be having problem getting all this done because the problem, I don't face the problem because I know what I'm doing, but because maybe it's your first time, you will face some problem. So I would encourage you to try and do this now in this session so that if you have any problem, you can ask me, or you can ask also any other questions. I think I will just leave this as is, and I will open for question and answer, and I will just keep answering question if you have any questions. We have 2 more here, so keep the question coming. Arduino, maybe you need to install the one from the website. Did you install from the Windows Windows installer? The one from the Windows is not so stable, I think. You can download the standalone one. That one you can try. Standalone Arduino. Standalone Arduino. Okay. Okay, can I control my friend and not MCU which is far from me using phone if I have the IP address? Yes, if you are in the same network. Okay, for example, you are in your house. Your house. Okay. Your house have a router. Your router address is 192.168.0.1. This is your router. So when you get an address, you will get maybe .13. So this is your router. Whoever is connected to this can talk to each other. Right? For example, you have not MCU connected here. The IP address of the not MCU is 192.168.0.14. Your router is actually 1 lah. Then you have one more here, 192.168.0.5. For example, this is your laptop. Okay, so any client that is connected here can connect to the not MCU server. Okay, it can connect to the not MCU. But if it's on a different server, this is another server, or maybe this is the internet. Okay, the internet. So if you are from the internet, you cannot access this IP. You can only access this IP from outside the from inside the local network. If you want to access it from outside or from outside the internet, there are ways to do it, but I will not cover it here, but it is possible to do it. This actually doesn't matter how far you are from, as long as you are in the same network. So, for example, in the university, if the university allow us to go in without any username and password, I can be in SKE and I can connect to the one that is in SKM if they use the same network IP. So it is possible to do that. But it only depends on the IP address. You can also access it from the internet. There are ways to do it. But it will take some, there will be some challenges lah. So in this case, maybe Blink have an advantage because Blink already set up everything on the internet. So you can connect from the internet directly using Blink. By using this, you still need more setup in order if you want to connect to the internet. But Blink already take care of that for you. Oh, okay. This may be the guy who asked about the turn off relay from use relay to turn off ESP32, right? Maybe that one. Yeah, this is the same actually. The same code that you have now with you, the one that I give to you. This one is turning on LED. Right, this one is turning on LED. But actually it can turn on anything that you want. LED is just a representation of a device. You want to turn on a computer, you can. You want to turn on your fridge, yes, you can. You just connect. Yeah. You want to turn on your toaster machine. Yes, you can. You just need to send on and off, right? To turn on something. So, but the thing is, here you need to connect to a relay. Relay connect to 240 volt for the toaster, and here you connect your on off just now from the not MCU. So whenever you turn on or off, although I show as LED, but whatever that is digital, for example here relay, you can turn on and off the same way. Now, just with the same code you have just now, you can use your voice to turn on your toaster. Just add a relay. Or you can use your voice to turn on the fan. Not the wall fan. You need to have a more difficult connection for that. But if you have a stand fan, just plug this to a relay. Then the relay to the then you can control from your mobile phone. You can say turn fan on, then it will turn on because it will just give you 0 and 1, right? Then the relay will turn on and off, and when the relay is on, it will connect the voltage to the fan, then it will turn on. So you can turn on anything. You can turn on microcontroller by using the same relay. Just connect the output to 5 volt and connect it to the V-in of the microcontroller. That is possible, but you need to have another microcontroller here to control this microcontroller, which I don't really understand why you need to do that to turn off microcontroller. Usually you don't turn off or on microcontroller. You use the microcontroller to turn off or on something else. So that is usually what you do. Okay. I think I will start answering question here until the end, until nobody have any more questions. Based on the tutorial that you do on the notes that I have sent. Why I can't paste the web server to the Arduino? This one I don't understand. Why I can't paste the web server to the Arduino? What is the question? You want to clarify? What is the question? Why I can't paste the web server to the Arduino? Anyone? Who is this? I don't understand your question. You cannot paste the web server. You want to clarify? Or else I go to the next question. Or maybe I'll come back to this later when you are ready. Setup code because inside only before voice. Full setup code. The code you can get from the link. Full setup code. Yeah. Yeah, the code actually is from the link and also in the link. You can get the whole code from the link. Here, you have the link in the notes. Sorry, wrong. Here, you can get the code is actually this one. All the code is here. You just copy and paste. Okay. Where was I? Mana dia? Okay. Yes, Mqtt Inventor can do real-time monitoring system. Definitely. You know the one that we did, the 3 second. That one you can do maybe less than 3 seconds, maybe 500 millisecond. I think that is enough real time for Capstone project. You don't need to do really real time, but this is actually quite fast. There is no problem to do real time monitoring system with App Inventor. You can even do graph. If you want to make graph, also possible to do graph. You need to, there is some tutorial that maybe I can share later on. You can use to make the graph. Okay, let me see this. Oh, this is baseboard. This one only baseboard. This one 5-volt power supply. Okay. Yes, you can use this to get the 5-volt power supply. Should be no problem. But you can also, if you have a not MCU, you can just use USB. USB, you connect to power bank. The power bank have a 5-volt, right? A power bank. So you just connect the USB to 5-volt power bank. There is now a very small power bank that can supply that. The one that you show here is called a breakout board. It is to, if you have a lot of connection outside, you want to put that there, and you want to have a power from the wall. Yes, you can do that. But you can also use a power bank to achieve that if you don't need to buy any more stuff. Okay. Sorry, the app you cannot download to the iPhone because it doesn't support iPhone yet. But you can download the iPhone app Inventor companion. iPhone app Inventor companion. You cannot install on the iPhone. The apps will run on these other apps on the iPhone. But I think for the purpose of what do you call that? The purpose of Capstone, I think this is okay. You can still run it, and you can show demo later on. But if you want to make really for iPhone, you need to use Tankable X, and this you can install on the iPhone straight away as there is an icon that says your app's names, and you can use it straight away. But this Tankable, the free version, there's a lot of limitation. It's very slow for the free version. It send you the file very late and things like that. My advice is, if you want to develop simple apps, just use the MIT App Inventor, test it out on the iPhone using the companion. Whenever you are ready, you think, okay, now all is done, you can remake the apps in Tankable, so that you can use directly install it on the iPhone. Okay. Yeah, the Arduino app. Usually the one from Microsoft, there is some issues, but the one from the website should be okay. The one installed from the website, I have not come to any problem with it. Maybe the problem is not Arduino itself. Maybe need to reformat your computer or something. I don't know any other options if you cannot install that. You can probably try the web version of Arduino. Not sure if that will work though with ESP8266. I haven't tried that yet, but maybe you can try that Arduino Web. If I'm not mistaken, Arduino Web. Solar power source. Solar power source. So you want to solar power source. Oh, okay. I think you want to use the sensor with solar power and also the SP32. So for this, if you want, you can buy a solar panel. Then you want to buy a I forgot the name. It's a charger controller. Charger controller. MPPT. Charger controller. So this one might be a 12 volt. You have the MPPT charger controller. What will this do? This will charge your battery. Maybe lead acid battery or lithium also can. If you lithium, you need to find a suitable charger controller. So 12 volt solar, then charger controller, either MPPT or others. Then charge your lead acid battery or your lithium ion battery. Then from your lithium ion battery, you can connect to ESP32 straight away. From the battery, you can connect to ESP32, and all the sensor will just be turned on when you turn on the ESP32, because all the sensor is connected to the power of the ESP32. Yes, you can do this. This is definitely possible. There is also another way that might be easier. There is not MCU or ESP32 that have built-in controller, charge controller for lithium ion battery. So you can just buy this. This one, maybe I'll show you very quickly. There are many. This is just one of them. Salah je. Salah. So the one that I show here doesn't support battery straight away. Like this one. This is ESP32 also. So you can see here, this is a battery pin. So the charger controller also already built in. You just need to buy a small battery, maybe 50, 20, 30 battery. So you can buy this battery and plug straight away into that. Then it will function from the battery straight away. But if you want to make it function from the solar straight away, some modification need to be done. So you have to look into that. Okay, solar power. Yeah, the slides are already on the GitHub. The one that just now we see GitHub. This one. The slide is here. The code is here. Even the, what do you call this? This AIA is actually the MIT App Inventor. MIT App Inventor file. You can upload this and you can get the code straight away. Slide recording. You have to ask Dr. Rashidah or the secretariat later. I think they will share. You want to power on MCU directly from the wall. If you want to power directly from the wall, the one that your friend or this one is suitable lah. This one, the one that you have here, you can copy and paste this. But this one is suitable if you still want to power it from the wall. You can also actually just power from the wall using USB. No need to have jumper. If you use USB, just plug straight away USB to the Nodemcu. No need to use jumper. The USB charger cable directly to the Nodemcu, and that is enough. Okay. Last question. Is there any more question regarding MIT Inventor or Nodemcu? Okay. You want to set to be done automatically. So you want to set it to be done automatically. You can use milis to do this. Or you want, yeah, I think you can just set a timer. It should be okay. You need to set a timer of when it will turn on and when it will turn off. and I think that should be enough. This is just timer coding for
Yes,
not
Doctor,
MCU.
but sorry Doctor, for interrupt, but this will be daily, not 15-second or anything like this. It will be like I need to use the system every day or 2 days a week or anything like this. Is there any way can I access the calendar or anything like this?
No, not with not MCU. But oh, okay, maybe you can access the calendar using REST API. The one that we just made just now is our calendar, our not MCU become server, right? So if you want to access calendar, why is it? I want to open another. Here. Okay, if you want to access a calendar, maybe you can access calendar REST API. Google have a calendar REST API, meaning maybe this one. REST API is the GET, you know, the GET that we used just now. Sorry. Maybe this one. You remember we use LED/on? This is the instruction we send to the server. But actually, this format is used all over the web. So if you want to get a calendar value, you need to find some provider that provide the calendar value. I think even Google, they can give you the dates. So you can extract that, meaning you use REST API with not MCU to get the value of the calendar, the dates, and then you can use the dates to process further. That is definitely possible.
Okay, Doctor, thank you.
Okay. Maybe this one. There's a lot of calendar API here. So let us see if there's anything easy to do. All says easy. So API is actually application interface. So whenever you want to interface with other apps, you can. So for example, if you want your not MCU to read data from Facebook, Facebook have their own API. You can actually read data from Facebook. You can even take picture using your ESP32, then post on Facebook. It is possible because they give you this API, the interface. This is actually just the get, post, delete, the instruction you send in order to get response. Right. So, but you need to send this in a special way. So all this API, they actually open for everyone to access. For example, here you need to do certain things for security purposes. And then after that, you need to send data with this message. Whenever you send the data with this message, they will respond with certain things. So that many companies in the world, they already have their own API. Telegram, you can send a message to Telegram. You can send message to Twitter, WhatsApp. WhatsApp not so open the API, but you need to see the API and see how open it is for you to do things. I can, for example, if I learn the Facebook API, I can set my ESP32 to take picture every 10 seconds and then post the picture every 10 seconds to Facebook. Automatically, you don't need to click anything. It's automatically done. So that is possible. So what you want to look for is REST API. REST API for that particular function. So for you, you want to look for REST API calendar. Then you will find many calendar that will give you a function of how, if you want to get the dates, this is the format you need to request from the server. If you send the request correctly, then they will send you the dates back to you. Okay, let me go back to the question. Sini lah. Okay, can we make a pop-up notification using Mqtt Inventor? There is one thing called notification. I have never. Let me see. What's my Mqtt tadi? This one. There is something called notification you can use in connectivity, social, sensors, thermometer, location, my notification, media, layout, no. Maps, you can use maps also, maps, texting, storage, experiment. Mana pergi notification? Oh, notifier, here, notifier. You can use notifier to make notification. And maybe I should mention also, using App Inventor, you can actually use many of the sensors that is already available on the phone. For example, you want to use accelerometer sensor. Somebody dropped the phone. You can detect somebody is dropping the phone. Or you want to move the phone and let the robot move together with the accelerometer value. Yes, you can do it with App Inventor. Barcode scanner automatically built in. You can just run it straight away. You don't need to program anything. Just drag this here. It automatically create a barcode scanner that you can just call. For example, here. Sorry. You can just call scan whenever somebody press the button 1. You can just call scan, and when you get the value of the scan, then do something with the value of the scan automatically from here. So it's quite easy. What else can you do? Light sensor, location sensor, near field sensor, orientation sensor, proximity sensor, gyroscope, even thermometer that is available in your phone. All that you can actually access using Mqtt App Inventor, and you can do stuff with it. For example, light sensor, you want to turn off your system at night. Whenever it's dark, then you automatically turn off. You don't need to even buy anything. You can just use directly the sensor that is available on your phone. So that is also possible. All right, let me go back to the question if there are any more. There is some more. Yes, you need to download the APK again if you change something on Mqtt App Inventor. But if you want to test, you don't need to install every time. You can actually use AI Companion, where you click this, you install AI Companion on your phone, and then you just scan. This one, iOS also can use, if I'm not mistaken. iOS also can use this, so you don't need to install on your phone yet. Make sure everything is perfect first. So if you install this and you run this, you don't need to wait. If you change something here, it will automatically be on the phone. You don't need to install or anything. Automatically, it will update on the phone. But after you finish development, then you want to start installing, then you do this one. The reason I do this example instead of this example is because at the end later you want to do this. You want to make your own app. So that's why I share this example instead of this. But you can definitely use AI Companion in order to monitor it directly without updating anything. Okay. Any more question? Before we stop the session, I will check the chat also. Okay, ada Google Form. Google Form to for attendance. And I think the session today is mostly about answering your question, which I think is quite good. If you want to have more session like this, just let me know. I can arrange for just a question and answer session. Maybe 1 hour session. You can ask anything about IoT. You want to use Blink. You want to use whatever other stuff, MQTT. You can we can arrange for a session for that, especially during your capstone project, especially to understand your capstone project better before you start making the project. So just let the coordinator know if you want to set just question answer session. If you are interested, I can set another session, 1 hour session maybe next week for just question answer. I probably cannot go into detail for with stuff, but I can guide you to the right place. Okay, any more final question before we stop the session today? Verbal question or question in Menti or in chat, all are welcome. I will wait 1 more minute. Then I will stop the session today. Okay, I think there are no more questions. Let me just do a short summary of what we have done today. So as a conclusion, today we have gone through the steps to understand how communication between Nodemcu and MIT App Inventor works. This is not only between Nodemcu and MIT App Inventor. You can communicate in between a lot of different internet client, laptop, server, tablet, all use the same method to communicate. Now we have an extra communication tools, which is the Nodemcu. It will also be able to do the HTTP request, either post, get, put, delete. So it can do all this. And we have shown how you want to communicate between MIT Inventor and Nodemcu using the get function. And you can also read the value from any sensor that you want, or send the value to any sensor that you want. We have shown that through the digital button, digital LED, and also the sensor that I have shown you just now. And I hope this gives you a good overview of how the system works. And one tutorial cannot really get you anywhere. That's why I prefer you to ask question, and I answer directly to your question, so that you are really solving the problem of your group. And maybe the one I share today is not relevant to you, but I hope the idea or the understandings of IoT and how it works, how it communicates with each other, will help you build a better product for your capstone project. I think that is all from me. If there are no more questions, I'll just open it for the last time. Okay, there are no more questions, it seems. I think if there are no more questions, I will say goodbye for now. That is all for the session today. I hope you learned something, and I hope everyone can try and finish the tutorial. Listening is different from doing. If you just listen, you don't really learn much. But even if you don't listen to me here, but you have a lot of tutorial out there online, and you do the tutorial, then you will face the problem, then you know how to make the solution. That is when you learn. So if you just come here to listen, I don't think you will get much. But thank you to those who ask questions. Thank you to those who try to do it. I hope you learn a lot during the experiment of trying. Even if you don't manage to finish it, you can still contact me to try and ask the question. If you need more question and answer session for specifics project, please let me know. We can arrange another session if need be. All right, I think that's all from me today. Thank you very much for the session. I'll see you probably in Capstone presentation later on. All right. Thank you very much. Bye.
Thank you, Dr. Fauzan, for sharing and clearing up all the confusion by answering all the questions very clear about the Internet of Things with Nodemcu and MIT App Inventor. Attention to all the participants. The recording of this workshop will be uploaded on YouTube and the link will be given in Capstone group WhatsApp. So don't worry. Okay, so don't forget to fill up the attendance form that is given in the chat box. Before we end this workshop, I would like to invite all the participants to turn on your camera for a photo session.
Ui, ramai ni 100. Muat ke? Ambil banyak page